Welcome back to ACO test question of the day. In today's video, we'll learn how the simple definition of a prime number can be written in a slightly complex way. So let's start with the question first, and then I'll tell you what I'm trying to convey here. So if I read the second part of the question, it says that x is a positive integer, and the condition for x is given as it doesn't have a factor p where p is between 1 and x. So if we do recall the basic definition of a prime number, what does it say? That a prime number has exactly two distinct positive factors. Means those two factors are 1 and the number itself. There cannot be any factor between 1 and the number itself. For example, if I take, let's say x is 2, let's write down the factors of x, 1 and 2. So there is no factor between 1 and x. If I take x as 3, the factors are 1 and 3. But as soon as I try to take x as a non-prime number, then I can see there is a factor between 1 and the number itself. So this doesn't work, this does, this does. So this complicated statement implies that x is a prime number. Now the question becomes slightly simple, where the expression for a is given as 5 raised to power 15 minus 625 raised to power 3, and it says a by x is integer, where x is greater than 1. Then I need to find out the number of values of x which satisfy the given condition, which basically means I need to factorize this and see how many prime factors are available in A. So that means now I need to see the number of prime factors in A. So let's prime factorize it. That's 5 raised to power 15 minus, this can be written as 5 times 5 times 5 times 5 raised to power 3, which is 5 raised to power 15 minus 5 raised to power 4 raised to power 3. 5 raised to 15 minus 5 raised to 12. I can take out 5 raised to power 12 common. So that becomes 5 raised to power 3 minus 1. If I further rewrite it, 5 raised to power 12. Now 5 cube is 125. So that's 125 minus 1. So the final expression for A is 5 raised to power 12. And this is 124. If I further break it down, 5 raised to power 12 into 2 times 2 times 31. So if I have to see the prime factors in A, those prime factors are 1 is 2, 1 is 5, and the other one is 31. So hence I can say there are 3 different values of x which will satisfy the given condition. Subscribe to our channel to see more videos like this.